Awesome. We're live. Here, I'm just gonna put our thing. There we go. That's much better. Well, since no one is here, I guess I'll just be doing some problems. Okay. I see. Here, where should I put this? This. Okay. Let's do it. So right now, we're just gonna go over all the concepts we need to do for this quiz. We're seeing L'Hopital's rule, then we're seeing approximation and errors, and then implicit differentiation and related rates. So I'm going to share my screen. Yeah, let's share the entire screen, right? Oh, hey, what's up? I think I remember you from last time. How have you been? Thank you for joining. Yeah, we're going to do some more problems. You guys can see my screen, right? I mean, good. Okay. All right, good. It's good to hear that. Hold on. Let me see if I remember you. Were you a senior? Okay, no, I don't think I exactly. I mean, I remember you were in the live stream, but I don't think I remember you personally. The tutor, yes, that's the one. Yeah. Thank you for joining. Yeah. Actually, I think you were the one that helped me with the approximation and errors one. Yeah. All right. Yeah. Well, thank you for your help. Yeah, I'm just gonna be doing all these problems again, so I can be ready for the quiz. But yeah, let's do this. Oh wow, 3 people are here already. Welcome everyone. Thank you all for joining. It's very cool to have you here. So we have the limit as x tends to 0 of x to the power of 3 over sine of x minus x. All right, yeah, I'm not gonna see the answer. So let's see. So if we plug in 0, do we get an indeterminate form? So we get sine of 0, which is 0. 0 minus 0 is 0. So we get 0 over 0. Yes, that's an indeterminate form. So it looks like we got to apply the rule, apply the derivative to both sides. D dx of x to the power of 3 over d dx of sine of x minus x. So the derivative of x to the power of 3 is 3x squared, and then the derivative of sine of x minus x with respect to x, that's cosine of x minus 1, I think. Yeah. Now, is that an indeterminate form? So let's plug in 0 again, and we get, well, 3 times 0 squared, that's 0. So we get 0 in the numerator, over cosine of 0, which is 1. Oh, so we get 1 minus 1, and that's also 0 over 0. So we got to apply the rule again. Oof, okay. So we get the limit as x tends to 0 of d dx of 3x squared over d dx of cosine of x minus 1. And so what's d dx of 3x squared? That's 6x over, and then d dx of cosine of x minus 1. That's negative sine of x, negative sine of x. So plugging in 0, we get 0 over, oh, 0 over negative 0, which is also an indeterminate form. So looks like we got to apply the rule again. Okay. So then we apply d dx to 6x, and then that's over d dx of negative sine of x. Then we get 6 in the numerator, and then we get negative cosine of x in the denominator, I think. And then plugging in 0, we get 6. Oh, okay, cool. Over negative, oh wait, so cosine of 0 is 1, so negative 1. So we get negative 6, and is that what? Let's go. Okay, cool. Yeah, I think we got this. Here, let's see. Are these like the more complicated ones? All right. All right, I guess we should go over them, right? Yeah. Um, let's see. So you always think of L'Hopital's rule as like if the numerator or denominator grows or shrinks faster. Okay. If it's x over a natural logarithm of x, and it's as it goes to infinity, you know that the natural logarithm of x grows slower than x. Right, yeah. Okay. Oh, so that means the entire function will grow towards infinity. Yeah, yeah, that makes sense. So you got a bigger over smaller, so it's going to be infinity. Right. Yeah, yeah. I guess that's a great way to view it. Yeah. Yeah, so I guess if we apply the perspective here, um okay, I don't know if it's a correct to view it in this one, but I don't know. I mean, we don't have one more. Oh wait, we have x tends to 0, so it's not infinity. All right, here. I guess I'll just, or in fact, I don't know. I think I know how to do this. I don't want to spend a lot of time. Okay, I guess let's do this one. Can we practice a similar one? Cool. Okay, so we have the limit as x tends to 1 of 5 to the power of x minus 5 over x squared minus 1. Okay. Well, all right, let's just check real quickly if we get an indeterminate form. Well, we get 5 minus 5, so 0 in the numerator, over x squared, so that's 1 squared, 1 minus 1. That's an indeterminate form for sure. So, looks like we apply the rule. So we have the limit as x tends to 1. So d dx, 5 raised to the x minus 5 over d dx of x squared minus 1. The numerator, we get, so 5 to the x, that's like an exponent form or whatever. So that's 5 to the x times natural log of 5, I think. That's minus 5 over 2x. So we get, so 5 to the 1, so that's simply 5 times natural logarithm of 5 minus 5 over 2. E to the power, what is 5? I don't know. I think that's it, right? So we have 5 times a natural logarithm of 5 minus 5. All of that over 2. Oh, wait. No. I'm sorry. Sorry. No. Oh, yeah. 2, right. And then for this one, we have the limit as x tends to infinity of tangent inverse of x over 1 over x minus 5. All right. So what does this mean? Tangent inverse of x over 1 over x minus 5. Okay. All right. Well, let's see if we get an indeterminate form. What's tangent inverse of infinity? Oh boy, I kind of forgot those inverse derivative rules. Well, okay. Let's see. I mean, we don't even need a derivatives in here. It's just inverses. Let's see. So tangent inverse of infinity. So that's sine of infinity over cosine of infinity. But then we have an inverse. Oh. All right. Oh wait, hold on. Okay. What do you do with a tangent inverse of x? Yeah, that's our arctangent um tangent inverse of x. I see. So what does that mean? Huh. Tangent. Not sure. Uh, do you also have a tangent inverse of x? Yeah, how should you view that? Tangent inverse of x to infinity, that's pi over 2. Hold on, wait, first, what is the range of tangent? So of tangent, we know that, okay, so first, the domain of tangent, that's, isn't it only the odd inputs in the unit circle? And the range, I think that's going to be infinity? And a negative infinity to infinity. Yeah, so if you plug in infinity, I think you get. Oh, yeah, because negative pi over 2 to pi over 2. Oh, so that's why you get a pi over 2. Yeah, because that's the upper number you can get. All right, so pi over 2 over. So 1 over infinity is 0. So you get negative 5, I think, right? 1 over infinity, that's 0. Yeah, so a negative 5. So I think we get something like, let's see, pi over 2, all of that over negative 5. I think we're correct. Crap. What happened? Um, ln of 5 minus. Oh, okay. Well, we got the second one correct. Interesting. But we didn't get the first. I was pretty confident about the first. So what happens here? So the derivative of 5 to the x is 5 to the x times ln of 5. Yeah. But then we plug in 1, and that's simply 5. Oh, wait. What about the minus 5? Oh, we forgot to get rid of that minus 5. Why? Hold on. No, we shouldn't have that. Yeah, so I think that should be correct then. All right, cool. Okay, I think we quite understand, right? Yeah. Uh, integrate root tangent dx. I'm not an integration yet, so I wouldn't know how to do that. Do you know how to integrate? Okay. Hold on. Wait. Root tangent of x. Root. Wait. Root. What do you mean by root? What does that mean? Root. Hold on. Did you say something raised to a root or a root raised to something? I'm not sure. Okay, well, we'll consider that. Yeah. I think I learned integration and I don't know. I think I'll learn it in like a couple weeks. So I'll keep in mind uh whenever I get a question. Root is square root. Oh, wait. So integrate the square root of tangent of x. Hmm. Why? I don't think I quite understand. Like a power of 1/2. Yeah. Oh, well, I mean, this is just, this is an inverse. I don't think it's, yeah, it's not a power of like a 1/2 or anything like that. And unless you're referring to something else. Let's see what could you be referring to? Yeah, no, I don't know. If I'm misunderstanding, what? Just try it once. That's what I think I should do. So here, let's open our Sketchpad. So are you asking just like random, or here? Let me get this pencil. For we can access that page. Why? Use draw. Yeah, that's good, right? So integrate root tangent of x. Gotcha. So something like that. Whoops, that looks a little ugly. Oh yeah, and then you put like the dx here. Well, I mean, do we have to do something like let's speed up my feed for some reason. Yeah, yeah. Let's see how to do it. Is it like within an interval, or just like in indefinite integral? I mean, I think we have to find like the antiderivative, but without the interval, I don't think I can apply the theorem. But here, what's the antiderivative of square root of tangent of x? So we can express this as tangent of x to the 1/2. And okay, so this would have been something like tangent of x to the 3/2, I think. And 3/2 times what gives 1? Well, 2/3, right? So I think would have something like, oh wait, but then we'll have to apply the chain rule. But then that'll have to give 0, or I'm sorry, 1. So uh huh. Well, no, that's a little tricky. Oh yeah, a u substitution. Yeah, no, I don't exactly know how to do that. Here, let's see. U substitution integrals. How do you do this? Is there like a Wikipedia page? Integral by substitution. So, integration by substitution, like U substitution. Oh, it's like a reverse chain rule. Oh, interesting. Okay. It's a method for evaluating integrals and antiderivatives. It is the counterpart to the chain rule for differentiation. Oh, that's genius, actually. I mean, yeah, that's exactly what we need. No, that's great. And can loosely be thought of as using the chain rule backwards. Different forms. Okay. So if we were to compute this, yeah, I mean, if you were to apply the derivative, we had needed the chain rule because we have a composition of functions. So set u to 2x to the power of 3 plus 1. So here we'd have u equals tangent of x. This means du dx equals 6. Okay, so then du dx would be secant squared of x. Now, oh, hold on. How do we get this 1/6 over here? What did we do there? Oh, wait, hold on. Wait. So, yeah, I mean, this is going to be like u to the power of 1/2. Oh, wait. Oh, so u du. Oh, so I think we get something then like 1/2 secant squared of x. And this, oh, so this is going to be like u, and this, a raised to the 1/2. And this is du. Oh, yeah, since we applied the derivative to u. Yeah, I guess that makes sense. But how did we get this 1 over a 6? I think I'm confused. Okay, it's fine. I'll just continue. Oh, so okay, so then I guess we do the integral of u to the 1/2 du. Then we get this 1 over. Oh, wait, are we applying the antiderivative then? So do we get some? Oh yeah, so 8 times 1 over 8 is 1 times u to the power of 7. Oh, okay. So I think we get something like 2/3 u 3/2, because 3/2 minus 1 is 1/2, and 3/2 times 2/3 is 1. Yeah, I guess that makes sense. What happened to the du? All right, and then yeah, plus the constant. I think I remember seeing that somewhere. Okay. Yeah, I don't know. Like that. I mean, I'm not exactly wrong. Sorry, right. Yeah, I actually don't know. Whoa. Why did he cut my hair? Long. I know it's much shorter now, but it'll grow. It'll grow. Oh wait, is u squared? Oh, so it's not u to the power of 1/2. 2 u du equals d. All right. Okay. Cool. Okay. So I think yeah, no. I don't think this is correct. But it's okay. I mean, I guess I'll do that problem again after I learn what integrals are like here. But in the meantime, I gotta finish this. Kind of got carried away. Let's see. Okay, so or let's do, which problem should we do? Wait, what is an indeterminate form? Wait, all indeterminate forms. Yeah, 0 over 0, infinity over infinity, 0 times infinity, infinity minus infinity, 0 to the 0, 1 to the infinity, and infinity to the 0. We're cooked. We need, hold on, let's see. Oh, I see. So all of these were fractions, but then here we don't have a fraction. So let's see what we do. So we have the limit as x tends to pi half. Oops, that arrow doesn't look very good. Times, of a cosine of negative 5x times secant of 3x. This equals 2. So replacing, hold on, wait. How do we get an indeterminate form though? If we replace pi halves, well, cosine of negative 5 pi halves, here, let's pull up the unit circle. negative 5. So we have pi halves. Oh, wait, hold on. Negative 5 pi halves. Pi halves. Sorry, negative pi halves. Negative 3 pi halves. Negative 5 pi halves. And we're cosine right here. That's going to be 0. So we get, oh, so all of that is 0. Oh, well, that's okay, right? The limit. Oh, I see. Okay. So because yes, we can express that as 1 over cosine. Right. So cool. Stop. What? What happened? Make this bigger. There we go. So we have the limit as x tends to pi over 2 of 8 cosine of negative 5x over cosine of 3x. Oh, I'm getting tired. Okay, so we get 0 over, and cosine of 0 is 1. And that's, okay, hold on, wait, sorry. Cos 8. So cosine of negative 5 pi halves is 0. So we get 0 over, and cosine of 3 pi halves. What's 3 pi halves? 3 pi halves, 3 pi halves. Right there. Cosine of that is 0. So we get 0 over 0. Hold on. Wait, so why did you say that we get like 0 to the power of something? That's not true. 0 times infinity, where did we get that? Oh, well, I mean, yeah, it's different. So, well, we get 0 over 0. Hold on. So, well, so now we have the limit as x tends to pi over 2 of d dx of 8 cosine of negative 5x over d dx of cosine of 3x. Okay, so 8, so negative 8 sine of negative 5x times negative 5 per the chain rule. All of this is going to be over negative sine of 3x times 3. So simplifying, we get 40 sine of negative 5x. All of that over negative 9. Whoa, sorry, that's not true. Negative 3 sine of 3x. And then plugging in pi over 2, we get negative 40 over and sine of 3 pi halves. Yeah, well, that's going to be negative 1 as well. So we get 3. So perfect. Exactly what I got. We're cooking, guys. Oh, all right, cool. Yeah, getting a drink is important. I have my water here. It's almost finished though. Cool. Oh boy. Let's see. Is there anything else that we need to know? All right, let's do this one. So we have the limit as x tends to infinity of x to the power of 5 times e to the power of negative x squared. Oh, that's tough. So let's plug in infinity and see if we get an indeterminate form, which we obviously will. Well, infinity raised 5 to the 5 is infinity, and infinity times e to the power of negative x squared. So negative infinity squared. So that's infinity times e to the power of negative infinity, and this equals to e times negative, infinity times negative infinity, and that's an indeterminate form. Wait, hold on. All indeterminate forms. Can we do infinity times infinity? Oh boy. Okay, hold on. So So we have 0 over 0, infinity over infinity, 0 times infinity, infinity minus infinity, 0 to the 0, 1 to the infinity, infinity to the 0. So we have x to the power of 5, infinity to the power of 5, that's obviously infinity. And then we have e to the power of negative infinity squared. Negative infinity squared. Oh, I'm sorry. I'm sorry. I see. I see what I got wrong. Well, e to the negative infinity squared. Well, negative infinity is 1 over infinity. And that's 0. So infinity times 0. Oh, hold on. Wait. Or infinity times 1? Um, wait. So this is e to the power of 0. That's not right. Hold on. So e to the power of what? E to the power of negative infinity squared. So that's the same thing as e to the power of 1 over infinity squared. So that's e to the power of 1 over infinity. E to the power of 1 over infinity. E to the power of. So 1 over infinity is 0. E to the power of 0 is 1. Hold on. So how did you do it here? Oh, okay. So if we express it like that, so we have x to the 5th over. Wait, okay. So if I don't know, x to the negative 5, that's 1 over x to the 5th. Right, So here we get infinity over e to the infinity. That's infinity over infinity in the determinate form. So we apply L'Hopital's rule. 5x to the 4th over e to the x squared times 2x. So now we input infinity, you get infinity over infinity times infinity. Yeah, we're just gonna keep repeating. So we have to do all of this? If for real? Okay. All right, yeah, so that's that. Beautiful. All right, so I think we're good on L'Hopital's rule. I think we're doing good. Yeah, limits are difficult. Yeah, I mean, it's just a practice in noticing patterns, but they're tough. Yeah, good luck if you're doing them. Got 4 people. Welcome, everyone. It's good to have you here, guys. Yeah, so I think we're good on implicit differentiation. Cool. Now we only need approximation and errors, and then we can begin our exam. Sadly, I can't record our exam. So what we're gonna do, I'm just gonna show my face. So you guys have to stare at my face. Yeah, okay. Well, oh boy, kind of tired. How are you guys doing? Let's put an emoji. Hello. There we go. Oh, that's cool. Okay. Why can't I access these? Channel level settings. I see. And how can I close this? Oh, organic chemistry. If that's what you mean, yeah. Yeah. That's tough. I think I also took that this semester, but I had to drop out because the load was heavy. Yeah. Hmm. Well, good luck. Yeah, that's a tough class. It can be stressful a lot of times. You know what always got me? I think it was like these significant figures. It wasn't even organic chemistry, but I mean, it always got me. It was I don't know. I don't know. It is they're just so hard. I don't know why. Ugh. All right, guys. Well, we gotta finish though. Yeah, you got this. I got this. Tell me how it goes. By the way, please. Yeah, if you ever have like an exam coming up, tell me how it goes. I'd love to hear about it. So we have. Okay, hold on. Let's remember what linear approximation is. So, oh wow. Kind of want to go outside, but it's fine. No, we got to finish this, and then we're gonna take the quiz. So, hold on. So, what do we got? So we have let f of x equals cube root of x using f and f prime approximate cube root of 8.1 by constructing the tangent line to f at 8 comma 2 and finding the point on this line with x equals 8.1. I see. Yeah, so if we plug in 8, we get um cube root of 8, and that gives 2. Yeah, so x equals 8 and y equals 2. So we start by sketching f of x equals cube root of x and drawing the tangent line at the point 8 comma 2. Right, so we'll get that. Cool. On the right above, we have zoomed in the graph near the point 8 comma 2. We see that the graph looks really similar to the tangent line near the point 8 equals 2. We can use this information to estimate f of 8.1. The tangent line to f at 8 comma 2 has slope f prime of 8. Right. So we need to compute f prime. So f prime of x equals d dx of cube root of x, and that's going to be 1/3 x to the power of negative 2/3. Right. So f prime of 8 equals 1/3 times 8 to the power of negative 2/3. Oh, so yeah, plugging in 8. Right, right, yeah. So we get 1/3 times, um, yeah, looks a little complex to solve that. It's fine. I mean, it's just a basic algebra. Thus, the tangent line we want passes through 8 comma 2 and has a slope 1/12. The equation of the tangent line is y hold on. Oh yeah, of the tangent line is y minus 2 equals x minus 8 right, times 1/12. Again, that's just over 12. So y equals x minus 8 over 12 plus 2. Plugging in x equals 8.1, we get we get 0.1 over 12 plus 2. That's 241 over 120. So that's how we do it. Oh yeah, and the tangent line through the point a comma f of a has a slope f prime of a. Yeah. Oh yeah, this gives us the point slope form y minus f of a. Oh yeah, y minus the y value, y1 equals f prime of a m times x minus a, x minus x1, or y equals f of a plus f of a plus f prime of a times x minus a. Cool. I think we understand. But I think we are understanding well. Here we only have 9 problems. Oh, I think I did this in a live stream as well. Yes. So, let's see. Let's see. We have 9 problems, and then after that, we do. Cool. Okay. All right. I think we're good. So, in fact, let's see. Let's open up the Sketchpad. Sketchpad. Canva. So, So we have the linear approximation at x equals 0 to f of x equals that is L of x equals a plus b of x. So we have f of x equals 1 over 4 minus x. I see. Huh. Okay. I see how this goes. And we need to find, L of x. So L of x is the linear approximation equation, I think. Plus bx. Cute. So what does this mean? Oh. So what are we gonna do? How do we do this? Oh yeah, how did we do this? So we have f prime of x equals, so we find the derivative. Why? Oh, okay. Well, I mean, if we want to construct the equation, yeah. So here we get f prime of x equals 1 over, yeah. So if we express this as 4 minus x to the 1/2, we get, oh yeah, and then we do prime. We get 1 over 1/2 times 4 minus x to the power of negative 1/2, right? How do you get something different? 2 times something to the power of 3/2. What? Why? I'm confused. How do you get that? Now that's wrong, isn't it? What did we have before? So 1, 5/4. Yeah, no, this is wrong. Yeah, I don't even know how they got that. Anyways, f of a, f prime of a, x minus a plus f of a, right? Yes. Right. F prime of x, or sorry, f prime of 0, x minus 0, f of 0. Oh, well, if that's the case, then here we do, so x equals 0. So we know that L of x equals f prime of x, ouch, no, just kidding, that didn't hurt, f prime of x times x minus a plus f of a. And this is going to be f prime of a. Yes. So here we get L of a equal L of or 0 equals f prime of 0 times x plus f of 0. That's right. So if this is our equation, then get 1 over 1 half 4 to the negative 1 half times hold on, wait. Yeah, times x. And f of 0 is simply 1 over 2. I think, right? Yeah. Hey, I think that's 1 over 2. Hold on. So, what does that mean? So, we have x over, so like this, times 1 half. And then we get 1 over 4, 4 to the a negative 1 half. Dude, you know what? Oh, I don't know what's going on here. I don't even know how they came here. How? Okay, I'm just gonna close this. I don't feel like. Okay, let's see. So, okay, let's do it with this problem. So we have 1 over square root of 8 minus x. Okay, so we need to get something like L of x equals, or if we have x equals a, or actually at 0, so L of 0, we have f prime of 0 times x plus f of 0. This is equal to, and the derivative of 1 over the square root of 8 minus x is going to be 1 half 8 minus x to the power of, okay, I think we forgot to play the chain rule. And then, and the derivative of negative x is going to be negative 1, I think. A negative 1, right, times a negative 1. So we get this times x plus 1 over square root of 8. This is equal to x over negative 1 half 8 minus x, a negative 1 half, plus 1 over square root of 8. Is it, let's see, is it this square root or square root of 8? I believe so. And then here we're going to have 1 over 1 half 8 minus x to the negative 1 half. Oh, at x equals 0. So there we go. Plus 1 over square root 8. That should be it. If that's not... Why is that not it? Oh, wait, no. Sorry. That's going to be times, whoops. There you go. Bro. Dude, I don't know. I mean, that's why. Oh, so okay. That okay. I see. I see. Um. Okay, so prime of x equals prime. Yes, and then we get negative 1/2, 8 minus x, negative 3/2. That's how they got that. I see. Times negative 1. So this equals to 1/2, 8 minus x to the negative 3/2. So if that's the case, which it is, we get negative 1/2. Oh, whoops, sorry, just 1/2, 8 to the power of negative 3/2. What's going on, bro? How don't we replace okay. Hmm. Oh, wait, hold on. So since this is under, so okay. Oh, there you go. No? Since it wasn't a fraction anymore. I mean, yeah. Oh, wait, hold on. Oh, no, sorry. I see, I see. Is it just that? Yeah, it's just that because the 1/2 is not. Okay, that's what we got wrong. I see what we got wrong. Oh, but okay. Mm, okay, well, I guess that's it. I think we understand overall everything that's going on, but I guess I could review a little bit this a topic right here. Well, everyone, uh, I thank you for joining. It was a lot of fun having you here, and yeah, I guess I'll review that and then I'll take the quiz. Okay, yeah, I guess so. Okay, well, we'll see you later, everyone. I hope you'll have a good time. I'll see you on the next live stream.